Today we're going to go through exercise 21A, which is the gradient of the straight line. We're going to start off with the learning intentions. So the first thing that we want to be able to do today is to understand what a linear equation is. You've already seen linear equations before, but I'm just going to give you a quick refresher on them. Our main aim is to be able to find the slope of a line both graphically and algebraically, and also to know the four different types of gradients. So we want to start off with the question, well, what is a linear equation? So say I have two variables, and my two variables are going to be x and y. The relationship between them is going to describe some sort of a shape. So say for one purpose, one of my coordinates is going to be 1 and 2, which means that when x is 1, y is 2. And in another instant, when x is 3, y is equal to 8. So if I were to plot that on a plane, and let's pretend that this plane is very, very straight. Say that this is the point 1 and 2, and then this point here might be 3 and 8. And so when I try to graph a line through them, what shape that describes is a straight line, which means this has a linear relationship between these two coordinates. So what this line is, or what the purpose of this line is that every single point on here, every single x value, so from 1, 1.01, 1.02, and so on, there is a corresponding y value that fits on this line, that moves in the same way. So from there, we want to be able to describe this relationship as something more than just a line. So the way that we describe this relationship is through an equation that you may have seen before, which is y equals mx plus c. So this equation here has two very important points. The first point, or the first parameter rather, is this one, m. M is our gradient or our slope, which tells us what is the rate that x is moving in relation to y, or rather what y is moving in relation to x, because we know that x is our independent variable. It's very important that we look at this gradient because that's going to describe whether the relationship is positive, as in when as x increases, y increases, or if it's negative, so when x increases, y decreases, and so on. Our second parameter that's really important is c, which is our y-intercept. So where does this line cross my y-axis, which is really important to know, especially in real-life application problems such as wanting to find where the starting value is, which will be c. So we'll explore that a little bit later on, but what we're going to be looking at today is our slope or our gradient. So there are two things that we can call this, either the gradient or the slope. So you may have looked at this before, the gradient and the slope, and we want to think about, well, what is a gradient really? And what we just talked about before was that it is the rate of change. So looking at how y is changing according to x. So it's a ratio between how much the relationship rises. So we're looking at, well, how much does it go up for how much it goes across. So you might know this as m is equal to rise over your run. So let's have a look at these 2 points here and see if we can figure out how much they are rising or running, which will give us our gradient. So I'm going to draw these 2 points just in a little separate planes. So let's say that's the point 1 and 2, and this is the point here 3 and 8. So if I were to draw this in a little triangle that looks like this, what I can measure is, well, how much has it gone up by and how much has it gone across by. So let's have a look at our rise first. If before y was 2 and now it is 8, that means it has gone up by 6. In the same way, if before x was 1 and now x is 3, it has gone across by 2. And so what I can tell here is between these two coordinates, the gradient or the ratio is that it goes up 6 for every 2 steps it goes across. So what that means is that the gradient is 3. We can write this as 3 over 1, but we will want to simplify that to 3. What that means is, its most simplest form, for every rise in 3 points of y, it means we go across by 1. So this is the graphical approach to being able to find a gradient. In this case, and one last thing I want to point your attention to, is that my slope is going up. I have a relationship where as y increases, x also increases. So we get a line that looks like this. This is what we call a positive gradient. However, what we can also get is that as x increases, y decreases. So we get a relationship that looks like that, which we call a negative relationship. So that's the the graphical approach to being able to find the gradient. If you turn to your books now, your summary book, so just trying to get my layers together. There we go. So chapter 21, constructing and interpreting linear graphs. So it talks about over here finding the slope, the gradient of a line. And it talks about the upwards and downwards, which is a positive and negative gradient as we just discussed. But what we have here is the algebraic approach of finding our gradient. So we have this same idea, so m, which is equal to the slope, which is the rise over the run, so it's the relationship between these two. But we describe the rise and the run a little bit differently to how we described it before. So before we just looked at how much it had gone up by and how much it had gone across by. This is this exact same idea. These two formulas here are difference formulas. They tell us, well, what is the difference between y and what is the difference between x, which is exactly what we looked at before, but now we've just got it in a formula. So let's consider example 1. Find the slope of the line going through these 2 points. Now we can draw these 2 points up like we did before and draw a triangle and find the rise over the run that way. Or we can use our algebraic approach. So the first thing we want to do is label our coordinates. Now since these coordinates are looking so tiny here, and I think I'm going to write all over them, I'm just going to write them separately here so that I can label them. So 1 here, this is going to be my coordinate 1. We're going to call it x1, x2. Whoops, sorry. That's meant to be x1 and y2. Just get rid of that. Okay, we're going to call this x1 and y1, and this will be x2 and y2. Those are my 2 coordinates that I've got, and now that I've labelled them, I can just sub them straight into the formula. So the rise is equal to y2 over minus y1. So what we're trying to do is find the difference between these 2 here. I'm just going to sub them in, so that's going to be 1 minus 7, and the run is x2 minus x1, so it'll be 4 minus 1. So my slope, and if we just actually work that out, so 1 minus 7 is negative 6, 4 minus 1 is 3. So my slope is going to be negative 6 on 3, which is negative 2. And see how that's a negative over there? That tells me that this line over here is going to look like that. Okay, so that's finding a gradient given 2 points. With your last example that you've got in your book, it says finding the gradient of a straight line. So now we're looking at part B over here. Now we're looking at part B over here, where we have to find the gradient of a straight line. So they've given it to us graphically, and so we have 2 options. The first option is to draw that triangle in that we looked at before, and then find the rise over the run. And the other option is, of course, to write out our 2 coordinates and find the gradient there. So what I'd like you to do now is to pause your video and to figure out what the gradient of that is, and then resume it once you're ready. So the first thing we want to do is label our points. So that's x1, y1, x2, y2. And so our gradient is going to be 5 minus 3, y2 minus y1 over x2 minus x1. 5 minus 3 is 2, 4 minus 0 is 4, and don't forget to simplify it so your gradient is 1/2. You will only get either half a mark or no marks if you leave it as 2 over 4 instead of simplifying it to 1/2. The last thing I wanted to touch on for our learning intentions is the 4 types of gradients that exist. So we've already discussed 2 gradients. We've discussed our positive gradient, so that as y increases, x increases. So we've got a relationship that looks like that, and that's what we call positive. Our second one is as x increases, y decreases. So we've got a negative gradient. But say I've got on a graph, draw it down here. Here's my plane, and say my graph looks like this. Okay, let's label 2 points. So say that point here is going to be 0 and 2, and this point over here is going to be 4 and 2. So we can do the same thing where we find the gradient here, the rise over the run. So it's y2 minus y1, so 2 minus 2 over 4 minus 0. 2 minus 2 is 0, 4 minus 0 is 4. So 0 divided by 4 is just 0. So a line that is horizontal has a gradient always of 0. Okay, our last type of gradient, so I'll try to fit it in here on the side. Say this is my plane here, and this is my line. So say this point here is 2 and 0, and then up here we might have 3 and 0. So same idea, let's try the same thing with finding the gradient. So if we go y2 minus y1, we're going to have 0 minus 0, and 2 minus 3. So 0 minus 0 is just 0. Okay, the 4th type of gradient . The 4th type of gradient, if I were to draw on Cartesian plane, and there's my line over here. So this point over here is, say that's 2 and 0, and then this point over here might be 2 and 5, for example. Okay, so then to find our gradient, I can go y2 minus y1, so 5 minus 0, and then 2 minus 2. So 5 minus 0 is just 5, and 2 minus 2 is 0. What would the answer to this be? Well, we can't ever divide anything by 0. So think of it as I have 5 lollies, and there are 0 people. How many lollies does each person get? Well, there is no answer to that question. We have no idea. The answer in this case is undefined. So whenever we have a vertical line, our gradient is always undefined. Okay, so that's all you really need to know about gradients. I guess the final thing to remember is that we have the equation y2 minus y1, x2 minus x1, and we have 2 coordinates, x1, y1, and x2, y2. Now it doesn't really matter whether I label this one as x2, y2, and this one as x1, y1. Makes no difference which one I've called coordinate 2 and coordinate 1. But what does make a difference is if I call this one x2 and then y1. What you must do, and what you must make sure you do every single time, is that you keep it consistent. So if I'm doing this coordinate minus this one for y, then I must also do this one minus that one for x. Don't swap them around because you won't get the right answer. Okay, so to just really briefly visit the learning intentions, we've looked at what a linear equation is. We've looked at what a linear equation is. We have learned how to find the slope of a line graphically and algebraically, and we now know the 4 different types of gradients, positive, negative, 0, and undefined. So if you're not really sure about either of these, please do go back and watch the video. Otherwise, I'll see you in the next video, which will be on 21B.